The ground beneath the Pacific Northwest isn't just restless. It's alive with ancient fury and whispered secrets that echo through the ages. Picture this: towering peaks cloaked in glaciers, forests that hug their flanks like old friends, and communities below that thrive in their shadow, drawing strength from the very forces that could one day unleash chaos. In July 2025, a monster quake near Russia sent shockwaves racing through the planet, and the Cascade volcanoes responded in a way no scientist had ever seen before. They pulsed together, almost as if the entire mountain chain was alive, breathing in unison. For hours, Mount Rainier, Mount St. Helens, Hood, Shasta, all beating in the same rhythm, like Earth itself was ringing them like bells. But the mystery doesn't end there, because even without distant quakes, the Cascades have a history of sudden eruptions that rewrite landscapes and test entire cities. The question isn't whether these volcanoes will stir again. It's how and how soon, and what stories they'll tell when they do. July 29th, 2025. A monster 8.8 quake rips through the Pacific near Russia. Tsunami sirens blare from Alaska to Japan, hearts pounding in coastal towns as waves threaten to swallow shores. But hours later, something bizarre begins happening thousands of miles away. America's Cascade volcanoes start pulsing, almost like they're alive, their seismic hearts sinking in a dance that defies explanation. At first, scientists dismissed it as aftershocks. Megaquakes often send shockwaves bouncing through Earth like a bell being struck. But this wasn't random noise. Across the entire Cascade Range, from Mount Baker in Washington down to Mount Shasta in California, seismic monitors began picking up faint, rhythmic pulses. Not once, not twice, but in a repeating pattern, stretching for nearly 6 hours. And here's what made experts nervous. These weren't ordinary tremors. They appeared almost simultaneously across multiple volcanoes, synchronized like instruments in a hidden orchestra. The Pacific Northwest Seismic Network had never seen anything like it. Post-quake vibrations are common, but not this structured, not this widespread, and certainly not this regular. Dozens of bursts spaced out in perfect intervals, as if something deep below the Cascades was keeping time. Was this just harmless resonance, or the earliest warning signs that the quiet giants of the Pacific Northwest were stirring together? What came next shifted the entire conversation, because one volcano in particular began acting very differently. And the first to draw attention, Mount Rainier. At 12:17 p.m. on July 30th, barely 8 hours after the Kamchatka quake, a strange swarm of long, low-frequency pulses began echoing beneath its southeastern flank. They weren't loud, they weren't violent, but they were too precise to ignore. Within minutes, the same signals appeared under Mount St. Helens, then Mount Hood, then the Three Sisters in central Oregon. One by one, the Cascade volcanoes seemed to answer Rainier's call. Automatic alert systems quietly triggered across the Northwest. But here's the twist. None of the volcanoes showed eruption signs. No harmonic tremors that usually suggest magma is rising. No GPS shifts to show the ground swelling. No sudden gas release. Yet the signals pulsed on, steady and coordinated. By evening, USGS and top university scientists had convened in an emergency session. The verdict? These were not random aftershocks. They were transient, tremor-like pulses, eerily similar to what's seen before eruptions, just without any of the physical changes that normally come with them. So, if the mountains weren't preparing to erupt, what exactly were they responding to? According to Dr. Alina Valdez, it's not an eruption signal. It's more like the mountain is listening, responding to a global pressure wave. And Dr. Andrew Forrester added, these pulses came every 11 minutes, like clockwork. That kind of timing does not happen in geological noise. What made this so remarkable wasn't just Rainier. It was the sheer scale. Data from more than 40 seismic stations lit up at once, showing tremor pulses across nearly 14 different volcanoes. Each signal was faint, but they carried the same rhythm, like the entire mountain chain was keeping time with an invisible metronome. Scientists compared it to a bell choir, each volcano chiming in when struck by a planetary shockwave. But here's the mystery. No one could explain why the Cascades would sing together like this. Dr. Tessa Nakamura described it this way. It's as if the whole arc of the Cascades was gently wrung out, not violently, but just enough to make the mountains hum. And then, almost as quickly as it began, the signals faded. By August 1st, the strange pulse was gone. No eruptions, no ground swelling, no abnormal heat on satellite scans. Official alert levels still green, but the scientific community buzzing with questions. To deepen the intrigue, let's weave in the voices of those who've known these mountains longest, the indigenous peoples of the Pacific Northwest. For the Cowlitz tribe, Mount Rainier isn't just a peak. It's a living entity in their legends, where it once argued fiercely with its wives, Mount St. Helens and Mount Adams, in a tale of jealousy and eruptions that reshaped the land. Imagine the emotional weight. These stories aren't mere myths. They're oral histories passed down through generations, warning of the mountain's tempers and the need for respect. The Klamath people speak of Crater Lake's birth from a cataclysmic eruption nearly 8,000 years ago, where gods battled and the sky darkened with ash, creating a sacred blue jewel that's now a cultural touchstone. These narratives add a layer of soul to the science, reminding us that the Cascades aren't just geological wonders. They're woven into the cultural fabric, inspiring art, ceremonies, and a profound sense of place for communities that have coexisted with their volatility for millennia. The quake that sparked all this wasn't ordinary. An 8.8 release of energy is enough to shift entire plates, not just shake local coastlines. These events ripple outward, redistributing stress across the planet. And the Cascades, resting on their mix of faults, fluids, and magma chambers, acted like tuning forks, hypersensitive to the slightest change. So the question became, were the Cascades simply vibrating like struck strings? Or were we witnessing something deeper, a direct interaction between a megaquake and dormant magma systems? Dr. Ian Niles of Stanford put it best. Think of these volcanoes like tightly wound springs. You don't need to snap them for them to respond. Sometimes the gentlest nudge can set them wobbling. And history reminds us St. Helens erupted in 1980 with only weeks of warning. Rainier, with its glaciers and lahar risks, could be even more dangerous if nudged the wrong way. By early August, researchers began digging into the anomaly with fresh tools. Using matched filter analysis, they compared the Cascades' mysterious pulses against decades of seismic archives. What they found was surprising. The signals looked less like eruption tremor and more like deep, slow-slip earthquakes, the kind that occur silently along hidden faults. But that raised an even bigger question. Was the Kamchatka megaquake nudging the Cascades' buried faults into motion? Another theory went further. Some scientists whispered about resonance, standing waves rippling through Earth's mantle like sound through a cathedral. Imagine the entire planet ringing like a bell, its vibrations transferring energy to the Cascades' partially molten underworld. If true, this wasn't just seismic noise. It was Earth itself, playing the volcanoes like instruments. At Mount Rainier, sensors recorded tiny but measurable heat changes near fumaroles. At Shasta, geophones detected the first unusual ground noise in years. Japanese and Russian monitoring stations picked up sympathetic tremors in their own volcanic arcs. It was as if volcanoes across hemispheres were quietly acknowledging the same planetary jolt. And that left scientists staring at a startling possibility. Are volcanoes worldwide connected by invisible threads of seismic energy? Dr. Wren of the Global Seismology Institute summed it up bluntly. Volcanoes don't act in isolation. They are part of a planetary system that responds together. For the first time, it seemed the Cascades had proven him right. Expanding on this global whisper, consider how these connections mirror the interconnected lives of Pacific Northwest communities. From Seattle's tech hubs to Portland's vibrant art scene, the region's economy pulses with the same rhythm. Timber from volcanic-enriched soils, tourism drawn to the majestic peaks, and even geothermal energy experiments tapping into the heat below. But this bounty comes with emotional stakes. Families in small towns like Enumclaw or Orting live with lahar evacuation drills as part of daily life, their resilience forged in the face of potential disaster. Socially, these volcanoes foster a unique bond. Annual festivals celebrate Crater Lake's indigenous heritage, while hiking trails on Hood draw adventurers seeking that thrill of standing on ancient fire. Yet, the 1980 St. Louis Helens blast crippled agriculture, halting exports and costing billions, a stark reminder that prosperity and peril are entwined. By that weekend, a cautious consensus began forming. What the Cascades had experienced wasn't magma surging upward. It wasn't eruption tremor. It was something new, what scientists started calling volcanic micro-resonance. Energy from the Kamchatka quake had traveled not just through the crust, but possibly into deeper magma reservoirs, causing subtle oscillations without eruption. In other words, the mountains may have briefly exhaled together. At the University of Washington, Dr. Shaw Weber noted that GPS stations registered tiny, synchronized shifts across multiple peaks, as if the entire volcanic chain flexed for a heartbeat. In southern Oregon, Newberry Caldera's geothermal output ticked upward just enough to catch attention, and offshore, hydroacoustic sensors captured faint, low-frequency tones beneath the Cascades themselves, sounds no one expected from a supposedly quiet arc. Despite the strangeness, eruption risk remained low. Gas emissions stabilized. Satellite heat scans showed nothing unusual, and the tremor sequence faded. But the scientific implications were enormous. Nearly every major Cascade volcano had responded in unison to a distant quake, pulsing together like linked organs in Earth's body before falling silent again. Some researchers called it the first real evidence of tectonic volcanic coupling across continents. Others argued it proved dormant. Volcanoes are far more sensitive to planetary vibrations than anyone assumed. And a few asked the most unsettling question of all. If one megaquake can make volcanoes whisper in unison, what happens if the next one strikes before the echoes fade? And while that global connection remains a mystery, one fact is undeniable. The Cascades don't need a distant megaquake to be dangerous. On their own, these mountains have a history of eruptions powerful enough to rewrite landscapes and threaten millions. The Pacific Northwest isn't just home to forests, coffee, and tech giants. It sits on top of a chain of volcanoes capable of rewriting history in a single day. From Northern California to Canada, the Cascades are a lineup of some of the most dangerous peaks on the continent, many of them towering over millions of people who rarely think about what's beneath their feet. Just this summer, Mount Rainier reminded scientists how alive these mountains really are. More than 1,300 small earthquakes shook its slopes in only a few weeks, the most ever recorded there. None were strong enough to knock dishes off shelves, but together they signaled that deep underground, something was moving. And if history has taught us anything, it's that ignoring those signals can be costly. Mount St. Helens proved that in 1980, when it tore itself apart in one of the most violent eruptions in U.S. history. That was one volcano on one day. But there are more than a dozen giants here, each one with the potential to change the Pacific Northwest forever. Now, let's infuse this with the raw emotion of history. Long before European settlers arrived, the Cascade volcanoes were sacred sentinels in indigenous lore. The Klickitat people's legend of the mountains tells of two brothers quarreling over a beautiful woman, their battles forming the Columbia River Gorge and the peaks themselves. A tale of love, rivalry, and creation that mirrors the dramatic geology. For the Yakama, Mount Adams, Pato, and Mount Hood, East, embody sibling rivalry, their eruptions seen as outbursts of anger. These stories aren't folklore, they're emotional anchors, teaching harmony with the land and warning of the consequences when balance is disrupted. Culturally, they've inspired petroglyphs, dances, and modern art installations in places like Seattle, where volcanic motifs symbolize resilience amid urban growth. Not all volcanoes are built the same, and the Cascades are the worst kind to underestimate. Unlike the broad, slow-moving shield volcanoes of Hawaii, most Cascades are stratovolcanoes, steep, layered peaks made of hardened lava, ash, and shattered rock. That mix makes them unstable, and when they erupt, it's rarely gentle. Stratovolcanoes specialize in explosions, towering ash plumes, fast-moving pyroclastic flows, and floods of mud and debris called lahars. The reason they exist at all lies far offshore. The Juan de Fuca Plate, a chunk of Earth's crust sitting under the Pacific Ocean, is slowly sliding beneath North America. This process, called subduction, drives water and minerals deep into the mantle, melting rock into magma. That magma has only one way to escape: up. And where it reaches the surface, it builds volcanoes like Mount Rainier, Mount Hood, Mount Shasta, and dozens of smaller cones that dot the landscape. Stretching for more than 700 miles, the Cascade Arc is a volcanic assembly line. And while not every peak erupts often, history shows that any of them can. That unpredictability is what makes the Cascades so dangerous, and why scientists treat every tremor, every gas leak, and every bulge in the ground as a potential warning sign. The Cascades have a rhythm, long silences broken by moments of chaos. And when those moments come, they can rewrite landscapes overnight. The most famous example is Mount St. Helens in May 1980. After weeks of tremors and swelling, the mountain's north face gave way in the largest landslide ever recorded. That collapse uncorked a sideways blast so powerful it flattened forests across 230 square miles and sent ash circling the globe. 57 lives were lost. Billions of dollars were spent in recovery, and the Pacific Northwest learned just how destructive one volcano could be. But St. Helens is far from alone. Mount Rainier, the tallest peak in the Cascades, has erupted many times in the past 10,000 years, and its icy slopes mean even a small eruption could unleash massive lahars barreling into nearby valleys. Mount Hood erupted in the late 1700s, its ash and lava flows reminding Portland that the mountain is anything but dormant. Farther south, Mount Shasta has erupted repeatedly over the past 4,000 years, while Mount Mazuma's colossal eruption 7,700 years ago created Crater Lake, one of the most dramatic volcanic scars on the continent. Even recent history holds reminders. Mount St. Helens stirred again in 2004, this time growing a new lava dome over the course of 3 years. It was quieter, almost surgical compared to 1980, but proof that the volcano is still very much alive. The pattern is clear. Cascades volcanoes don't erupt often, but when they do, the results are catastrophic. And the silence in between? It's not reassurance, it's buildup. Socially, this buildup shapes lives in profound ways. In the late 1800s, logging and mining booms drew settlers to the range, building communities on fertile volcanic soil that now support thriving economies, from apple orchards in Yakima Valley to ski resorts on Hood. Yet, the shadow of risk looms. A major event could disrupt supply chains, as seen in 1980, when ash contaminated crops and halted trade, costing millions in agricultural losses. Today, with populations swelling, places like Tacoma face lahar threats that could evacuate tens of thousands, testing social fabrics woven from pioneer grit and modern preparedness. It's an emotional tightrope, pride in the land's beauty mixed with quiet vigilance. For years, the Cascades have been mostly quiet, but recently, that silence cracked. In July 2025, Mount Rainier experienced its largest earthquake swarm ever recorded. More than 1,300 tiny quakes rattled the volcano in just a few weeks, at times spiking to 40 tremors an hour. Most were too small to feel, but to scientists, the message was loud and clear. Something was shifting deep inside the mountain. Was it magma pushing upward? The USGS says no. The data points instead to fluids moving through cracks in the rock. Still, it's a reminder that Rainier is active, complex, and unpredictable. And it wasn't just Rainier. Mount St. Helens, Mount Hood, and even Mount Adams have all registered small quakes and gas releases over the past year, the kind of background activity that scientists expect from living volcanoes. By early September 2025, USGS reported that all Cascade volcanoes remain at normal background levels. In other words, calm for now. But history shows that calm doesn't always last. Eruption cycles can shift suddenly, and swarms like Rainier's are exactly the kind of whispers that scientists watch for, because sometimes whispers turn into warnings. If history proves anything, it's that the Cascade volcanoes will erupt again. The real question is, which one and how bad will it be? Scientists consistently rank Mount Rainier as the most dangerous volcano in the United States. It's not just its height, it's the ice. Rainier is covered in massive glaciers, and even a small eruption could melt enough ice to trigger lahars, walls of mud and debris racing down valleys at highway speeds. For communities in Washington, that could mean as little as 30 to 40 minutes to evacuate before entire towns are buried. Then there's Mount Hood, just 50 miles from Portland. Its eruptions are typically smaller than Rainier's, but its location makes it a serious threat. Ashfall could choke highways, contaminate water supplies, and disrupt a metro area of over 2 million people. Farther south, Mount Shasta is one of the largest volcanoes in the range. It has erupted often in the past 4,000 years, and its position near key transport corridors means even a moderate event could cut off major highways and devastate local communities. And of course, Mount St. Helens, the repeat offender. Its crater still steams from time to time, and scientists consider it one of the most likely Cascade volcanoes to erupt again within our lifetimes. Another explosive blast like 1980 is unlikely thanks to the crater's collapse. But smaller dome-building eruptions, mudflows, and ashfall remain very real threats. Even the lesser-known peaks, Glacier Peak, Mount Baker, the Three Sisters, have erupted in the past and show signs of unrest. In other words, the danger isn't concentrated in one mountain. The entire arc is alive, and the next eruption could come from where it's least expected. The threats go beyond lava and ash. Power outages, flight disruptions, contaminated crops, and billions in economic losses are all part of the picture. A Cascade eruption wouldn't just be a local disaster. It could ripple across the entire country. The good news is that we've never been better at tracking volcanoes. Across the Cascades, a web of seismic sensors, GPS stations, gas detectors, and satellites keeps watch 24/7. At the Cascades Volcano Observatory in Washington, scientists study every tremor, every ground shift, every wisp of gas. That network means we'd almost certainly get early warning signs before the next eruption. Days, weeks, or even months of notice depending on the volcano. Communities near Rainier, St. Helens, and Hood already have hazard maps, evacuation routes, and regular drills. But there are limits. Monitoring coverage isn't perfect, and funding only goes so far. Some valleys still don't have dense sensor networks, and nature doesn't always play by the rules. A swarm of tiny quakes might lead to nothing, or it might be the first clue of something larger. Forecasting is still more art than science. So, is a major eruption imminent? Probably not. Right now, every Cascade volcano is officially at normal background levels. But the key word is right now. The quiet we're living through is temporary, and one day, it will end. The Cascade volcanoes aren't relics of the past. They're active, living systems. Mount Rainier's record-breaking swarm this summer is proof that these giants still stir beneath the surface, even if the ground above looks calm. History guarantees that another eruption will come. Maybe it's decades away, maybe longer. But as cities sprawl closer to hazard zones and glaciers retreat from warming climates, the risks grow more complicated. An eruption in the Cascades wouldn't just test scientists. It would test how prepared we really are, emotionally, socially and culturally. For now, the mountains rest. But rest isn't the same as peace. The silence will break. And when it does, how we respond will decide whether it's remembered as a tragedy or a survival story. Drawing from ancient legends where gods clashed and mountains were born of passion, to modern communities that honor this power through festivals and stewardship, the Cascades evoke a deep, stirring connection to our planet's wild heart. So, what do you think? Are the Cascades quietly gearing up, or just reminding us who's really in charge? Drop your thoughts in the comments and let's talk about it. Thanks for diving deep with me into the forces shaping our world. Subscribe if you crave more tales of Earth's untamed spirit.